Combustion.
Introduction. In the Stone Age, people never knew the use of fire. They used to eat raw food. It was by accident they found that by rubbing two stones, fire can be produced. They found that cooked food tastes better. Slowly, they started using dried twigs, coal, kerosene, and then gas to make fire. These, on burning, not only produced heat but also light. Burning of a substance to give heat and light is called combustion.
Combustion. A chemical process in which a substance reacts with oxygen to give off heat is called combustion. The substance that undergoes combustion is said to be combustible. It is also called a fuel. The fuel may be solid, liquid, or gas. Sometimes light is also given off during combustion, either as a flame or as a glow. In the reactions mentioned above, magnesium and charcoal are combustible substances.
Magnesium burns to form magnesium oxide and produces heat and light. We can perform a similar activity with a piece of charcoal. Hold the piece with a pair of tongs and bring it near the flame of a candle or a Bunsen burner. What do you observe? We find that charcoal burns in air. We know that coal too burns in air, producing carbon dioxide, heat, and light. Materials of combustion. Collect some materials like straw, matchsticks, kerosene oil, paper, iron nails, stone pieces, glass, etc. Under the supervision of your teacher, try to burn each of these materials one by one. If combustion takes place, mark the material combustible, otherwise mark it non-combustible. Is a chemical reaction in which heat and light are produced. Example, heated magnesium ribbon, when introduced into a jar of oxygen, burns, producing heat and dazzling white light. 2 mg plus O2 gives 2 mg O plus heat, light. Combustible substances. When paper, cloth, or wood comes into contact with fire, it burns. They are combustible. Try to do the same with a spoon, a glass piece, or water. They do not catch fire and hence are non-combustible. Substances which burn when brought into contact with fire are called combustible substances, and those which do not burn are said to be non-combustible. Supporter of combustion. Light a candle, invert a glass tumbler over it. What happens? It burns for a little while and then is put out. The candle burns by taking the oxygen of air. Once the oxygen is over, it is put out as the remaining gases like nitrogen, carbon dioxide do not support combustion. This principle is made use of in electric bulbs which are filled with non-combustible gases like nitrogen and argon to prevent the filament from burning. It is not only oxygen which supports combustion, but oxides of nitrogen and chlorine also support combustion. Supporting combustion. Place a piece of burning wood or charcoal on an iron plate or tawa. Cover it with a glass jar or a tumbler or a transparent plastic jar. Observe what happens. Charcoal stops burning after some time. Can you think of the reason why it stops burning? As there is no air to support burning, it stops. Ignition temperature. A substance that catches fire very easily is said to have a low ignition temperature or kindling temperature. They are called inflammable materials. Cooking gas, petrol, and white phosphorus have low ignition temperatures. Materials like wood and coal have high ignition temperatures. The ignition temperature of a material is defined as the lowest temperature at which it catches fire. Temperature. Make 2 paper cups by folding a sheet of paper. pour about 50 ml of water in one of the cups. Heat both the cups separately with a candle. What do you observe? If you continue heating the cup, we can even boil water in the paper cup. The heat supplied to the paper cup is transferred to water by conduction. So, in the presence of water, the ignition temperature of paper is not reached. Hence, it does not burn. The substances which have very low ignition temperature and can easily catch fire with a flame are called inflammable substances. Examples of inflammable substances are petrol, alcohol, liquefied petroleum gas, LPG, etc. Rapid combustion. Combustion that takes place at a very fast rate is called rapid combustion. LPG, liquefied petroleum gas, and dry grass are examples of substances which undergo rapid combustion. Sometimes a large volume of gas is liberated in combustion besides the production of heat and light. The sudden evolution of large quantities of gas creates excessive pressure that produces a loud noise. Such a combustion is known as an explosion. The bursting of crackers and the shot of a gun are examples of explosion. Slow combustion. Combustion that takes place at a slow rate with steady production of heat and light is called slow combustion. Burning of coal and rusting of iron involve slow combustion. In fact, respiration and digestion are also slow combustions. Spontaneous combustion. Oil paints, when thrown into a closed container or garage, spontaneously catch fire. The same phenomenon occurs in a haystack fire. Bacteria present in the hay cause slow oxidation of the organic material of the hay, resulting in the release of heat. When ignition temperature is reached, the hay catches fire. Combustion that occurs without the supply of external thermal energy is called spontaneous combustion. Incomplete combustion. Burn a candle. Hold a china dish over it. A deposit of soot is formed. This soot is nothing but carbon, which has not undergone combustion. Incomplete combustion takes place when camphor is burned. Incomplete combustion therefore results in formation of poisonous carbon monoxide, deposition of soot. Efficiency of the fuel is less as it does not produce the maximum amount of heat. Methods of putting out fire. Fire is a good servant but a bad master. Despite the best of care, fire sometimes breaks out in homes, schools, forests, theatres, slums, etc. Not only is there extensive destruction of property, but often many precious lives are lost in fire accidents. Thus, the methods of extinguishing fire are very important. What are the steps to be taken for putting out a fire? Break the contact of the combustible substance with the fire. Stop the supply of the supporter of combustion. Cool the burning substance below its ignition temperature. Sand and water are usually thrown on burning matter to extinguish fire. Sand covers the fire and cuts off the supply of air. Water cools the object and brings its temperature below its ignition temperature. Water also cuts off the supply of air, the supporter of combustion. Fire extinguishers. You must have seen fire extinguishers kept in schools, theatres, hospitals, business places, etc. Fire extinguishers are devices used to put off an accidental fire. They are painted red for easy identification. Let us now consider the various types of fire extinguishers that are effective for different types of fire. Sodium bicarbonate fire extinguisher. It consists of a large cone-shaped steel vessel containing a strong solution of sodium bicarbonate, NaHCO3, or solid bicarbonate. The bottom of the vessel is fitted with a metal plunger and a bottle of concentrated sulfuric acid. When in need, bang the knob or plunger at the bottom. It breaks the bottle containing the acid. The acid reacts with sodium bicarbonate solution, releasing carbon dioxide, which comes out through the nozzle and puts out the fire. Sodium bicarbonate plus sulfuric acid gives sodium sulfate plus water plus carbon dioxide. 2NaHCO3 plus H2SO4 gives Na2SO4 plus 2H2O plus 2CO2. Liquid CO2 fire extinguishers. Soda acid type. This is very effective as a household fire extinguisher. A cross-section of this fire extinguisher is shown in figure. A strong solution of sodium bicarbonate is kept in a metallic container, just above which a bottle of concentrated sulfuric acid is positioned. When the knob is struck, the acid bottle breaks, and the sodium bicarbonate solution comes into contact with the concentrated sulfuric acid. This produces CO2. 2NaHCO3 plus H2SO4 gives Na2SO4 plus 2H2O plus CO2. The carbon dioxide produced is ejected at the nozzle under pressure, together with the solution in the container. The carbon dioxide smothers the flame, whereas the water from NaHCO3 solution has a cooling effect on the burning material.
Types of combustion. Bring a burning matchstick or a gas lighter near a gas stove in the kitchen. Turn on the knob of the gas stove. What do you observe? Please try this experiment under the supervision of an adult. The type of combustion in which a material suddenly bursts into flames without the application of any apparent cause is called spontaneous combustion. We generally have fireworks on festival days. When a cracker is ignited, a sudden reaction takes place with the evolution of heat, light and sound. A large amount of gas formed in the reaction is liberated. Such a reaction is called explosion. Explosion can also take place if pressure is applied on the cracker.
Structure of a flame. Light a candle. Hold a glass tube with a pair of tongs and introduce its one end in the dark zone of a non-flickering candle flame. Bring a lighted matchstick near the other end of the glass tube. Do you see a flame? Notice that the wax near the heated wick melts quickly. The substances which vaporize during burning give flames. For example, kerosene oil and molten wax rise through the wick and are vaporized during burning and form flames. Effects of the flame. When the candle flame is steady, introduce a clean glass plate or slide into the luminous zone of the flame of a candle. Hold it there with a pair of tongs for about 10 seconds. Then remove it. What do you observe? A circular blackish ring is formed on the glass plate or the slide. It indicates the deposition of unburnt carbon particles present in the luminous zone of the flame. Hold a thin, long copper wire just inside the flame for about 30 seconds. Notice that the portion of the copper wire just outside the flame gets red hot. It indicates that the non-luminous zone of the flame has high temperature. In fact, this part of the flame is the hottest part. Characteristics of a good fuel. It must be easily available and inexpensive. It should be easy and safe to handle. It should be convenient to store and transport. The waste products of its combustion, such as smoke, soot, and ash, should be minimum. It should produce a large amount of heat in proportion to its weight. It should have a low ignition temperature. On combustion, it should not produce toxic products. Calorific value of a fuel. The calorific value of the fuel is the amount of heat produced when 1 kg of the fuel is burnt completely in oxygen. More calorific value, better is the fuel. Types of fuels. Fuels are classified as solids, liquids, and gaseous fuels. Solid fuel: wood, coal, coke. Liquid fuel: kerosene, petrol, diesel, alcohol. Gaseous fuel: water gas, producer gas, coal gas, natural gas, LPG, biogas.
Burning of fuels leads to harmful products. The increasing fuel consumption has harmful effects on the environment. 1. Carbon fuels like wood, coal, petroleum release unburnt carbon particles. These fine particles are dangerous pollutants causing respiratory diseases such as asthma. 2. Incomplete combustion of these fuels gives carbon monoxide gas. It is a very poisonous gas. It is dangerous to burn coal in a closed room. The carbon monoxide gas produced can kill persons sleeping in that room. Combustion of most fuels releases carbon dioxide in the environment. Increased concentration of carbon dioxide in the air is believed to cause global warming. Global warming is the rise in temperature of the atmosphere of the Earth. This results, among other things, in the melting of polar glaciers, which leads to a rise in the sea level, causing floods in the coastal areas. Low-lying coastal areas may even be permanently submerged underwater. Burning of coal and diesel releases sulfur dioxide gas. It is an extremely suffocating and corrosive gas. Moreover, petrol engines give off gaseous oxides of nitrogen. Oxides of sulfur and nitrogen dissolve in rainwater and form acids. Such rain is called acid rain. It is very harmful for crops, buildings, and soil. Use of diesel and petrol. The use of diesel and petrol as fuels in automobiles is being replaced by CNG, compressed natural gas, because CNG produces the harmful products in very small amounts. CNG is a cleaner fuel.
Solid fuels: wood, coal, coke, and paraffin wax are some important solid fuels. Wood has been a traditional fuel. Of late, however, there has been an increasing awareness that felling of trees for fuel could prove to be an environmental hazard. Coal is available in plenty in India. Coal is used directly as fuel or for the production of more valuable types of fuels such as coal gas and coke. Paraffin wax is obtained during distillation of petroleum. It contains a mixture of heavier hydrocarbons. It is used in the manufacture of candles. Combustion and light. Natural gas or marsh gas. This is formed in marshy areas. It consists of a mixture of methane and ethane. LPG, liquefied petroleum gas. The commercial fuel marketed as Indane is a mixture of butane and propane. Mercaptans are added to the LPG to detect leaks. Gobar gas or biogas. This gas is obtained by the bacterial action on cattle dung and water in circular pits in the absence of air. Methane and ethane are the main constituents of gobar gas. This fuel is becoming increasingly popular in villages because it is inexpensive.